Hey guys, today's mini lesson is the first of probably 3 mini lessons we're going to do on the division standard algorithm. When we use the term standard algorithm, we mean the efficient way, sort of the way that the people who know how to do it the very best typically do it. You may have heard your parents or someone else refer to long division before. And the standard algorithm for division is the long division algorithm. That's just another name for it that people use. It's not because the algorithm's long. It's actually much faster than partial quotients. But for whatever reason, it's called long division. I don't even actually know where that title came from. So I want to revisit real fast the partial quotients method. This is actually our exact example from last time. And so remember, our last mini lesson, we worked on doing the partial quotients method the fastest possible way. And the reason I showed you that is you pretty much do the same, it's the same idea in doing a fast partial quotient as it is to do long division. So I just wanted to review that again real quick with you. So what I'm going to do, I'm going to go to our first example. And here's how I worked it out last time. We're just going to do the ones on this side today. So I'm going to erase this. We'll come back to these another day. And I just want to think through, I don't want to think through this will be tomorrow. Just want to think through this example, 973 divided by 3. So when I did this the fastest possible way with partial quotients, let me remind you what I did. So I went to 973 divided by 3, and I said, okay, I'm just going to look at my hundreds, my 900s, and I'm going to try to make 900 with my 3 here. So I did 3 by 300, and that cleared out all my 900 right away, and I was just that fast. I was from 973 to 73 by just focusing on that first number. And then I said, okay, I'm going to do the most possible tens I can now. So I could do 3 times 20 and get 60 and knock most of my tens out, and then I just had one step left. So this idea where you're always looking at the first digit in the highest place that you have left, that's how we're going to do this with long division 2. So I'm going to work the same problem. And you're going to notice a lot of the same strategy still works here. I'm going to space it out a little. So much like the standard algorithm in multiplication, the standard algorithm in division, it's you have to put things in just the right spot. So I'm going to make sure I have plenty of room as I divide 973 divided by 3. Everything's got to go in just the right place. So here's what I do. So just like over here, I'm going to look at my 900s first. And I'm just going to ask myself, 3 times what will give me this 9? And just like I came over here, 3 times 300 makes 9. I'm just going to do that. My 3 times 3 gets me as close to 9 as I could get. It actually gets me exactly 9. And so then what I'm going to do is write down that 3 times 3, that makes 9. And I'm going to subtract that from that 9. I'm not going to worry about the 7 and the 3 just yet. So 3 is 9, and that leaves me with 0. So just like here, I lost my 900s and I had no hundreds. Now I'm down to 0 hundreds here as well. So now I'm going to deal with my 7, just like we dealt with the 7 next over here. I'm going to bring the 7 down here. And so in my first step, I was saying 3 times what gets me as close to 9 as I can go without going past it. Now I'm going to do 3 times what here gets me as close to 7 as I can possibly go without going over it. So I can do 3 times 2 is 6. If I did 3 times 3, I would be too high. I'd be at 9. I'd be past 7, and I couldn't subtract those. So here, we got our 300s, and then we got our 20, our 2 10s. We just did that here too. 3 times 2 is 6. Subtract those and get 1. And I'm going to bring now down my last digit, 3. And now I'm going to say again, what's 3 times what gets me as close to 13 as I can possibly get without going past it? 3 times 4 is it? 3 times 4 is 12. And that leaves me with a remainder of 1. There's nothing left to bring down, so I know I'm done because I've used all 3 of my digits. And so just like over here, I have 1 out of my next group of 3. 973 divided by 3, I can make 324 groups of 3. And 1 that doesn't fit. 1 out of my next 3. And we got the same answer. So that's how it works. You'll notice it's really similar, right? 300s, 300s. Then we did the 70 and did 60. Here's the 6 and the 70. And then, so it's almost the same steps. You'll see almost all of these same numbers over here and over here. This is just sort of the very final, most polished way to do it. Let's do one together. Let's go back here. So here's our we dealt with this one, 475 expo markers for 4 teachers. I'm going to get rid of this one. We'll do this one tomorrow. And so let's see what we can do. So you can pause if you want and look back through how we did this with partial quotients. And we're going to do the same one over here. 475 divided by 4. So I'm going 1 digit at a time. I'm going to try to do 4 times what gives me 4 as close as I can go without going over. So actually that's a pretty easy one. I can do 4 times 1 is exactly 4. And I didn't go over. So that's okay. So 4 times 1, and I write that product here. And then subtract it. And that is 0. So now I've dealt with my hundreds place. Now I do my tens place. So I'm going to bring down this 7. And I'm not looking at the 7 here. I'm writing my answer up here above each digit, but I'm not looking at the 7. I'm looking here. So my question is 4 times what is as close to 7 as I can get without going too far. 4 times 1 is 4, 4 times 2 is 8, so I can only do 1 without going over 7. So 4 times 1 is 4, and I can subtract those. And I get 3. Bring down the next digit. And now I'm saying 4 times what is as close to 35 as I can go without going over. 4 times what makes 35? Well, 4 times 9 would make 36. That's too high. So I can do 4 times 8 is 32. And I'm left with 3. I've dealt with all my digits, so there's nothing else I can do other than say if every teacher would get 118 of those expo markers, and 3 of the 4 teachers could get 1 more. Or they would get 3/4 of a marker, which is kind of a weird thing to say in that situation because they wouldn't really. 3 people out of 4 would get 1 more marker. So if you look again, notice just how similar these 2 methods are, right? 4 times 100, and here's my 400. 4 times 10 made 40. 4 times 10 made 40, 1 in the tens place. 4 times 8. 4 times 8. So the methods work out pretty much the same way. So that's the division standard algorithm. We will try 2 more when you get to class tomorrow.